Hi class, and welcome to another video lesson. We're on 9.4 notes day 2. We just did the first 3 problems on that notes. Those were variation problems. Now on the back page we're going to do 4, 5, 6, and 7. Those are rational expressions and rational equation type problems. So we're going to be getting some real world information here. We're going to set up some equations and we're going to solve them. They might not seem very easy when you look at them, but they definitely have a procedure that you go through that makes these much easier to solve. So make sure you take good notes on these, and I don't think your Excel math will be any problem for you. Here's number 4. Matthew can do a job in 4 hours. Josiah can do that same job in 6 hours. Maybe it's mowing a lawn or something like that. Matthew can mow this lawn in 4 hours, where it takes Josiah to mow this lawn 6 hours. Something like that. How many hours will it take the two of them if they do the job together? Well, the first thing you should be thinking of is that it's obviously going to be less than 4 hours, right? If Matthew can do it 4 hours on his own, well, now if he has Josiah to help him, it's going to at least be less than 4. So you can start doing some mental math in that way as well. So here's how you solve this one. Matthew can do one job in 4 hours. Okay, so 1/4. Josiah can do the same one job in 6 hours. So how long will it take them how long will it take the two of them to do this job if they work together? So how long they're going to work is going to be our variable. We don't know, so we're going to call it x. If they do it together, we're going to add up the 1/4 x and the 1/6 x. And that's going to equal our total job. So once again, it's Matthew can do one job in 4 hours. Josiah can do one job in 6 hours. How long will it take if they work together, so that's why we're adding, to equal that one total job that they need to do. And x is the amount of time that passes. That's going to be our variable. So for this one, the first thing that we have to do is we have to get a common denominator, because once we get a common denominator, now we can get rid of our fractions and solve. So between 4, 6, and this is 1/1, what's our common denominator? It would be 12. 4, 6, and 1 all go into 12. So now you have 12 times 1/4, distributing this 12 to all 3 terms. 12 times 1/4 is 3x. Plus 12 times 1/6 is 2x. That equals 12 times 1, which is 12. So now this becomes a very simple equation that you guys did back in the 5th grade, I suppose. You'd get 5x equals 12. And so x equals 12/5. And I believe that Excel Math answers their questions as a proper fraction here, which means, or as a mixed number rather. So I think they have it as 2 2/5 hours. That's how long it would take Josiah and Matthew to mow this lawn together. 2 2/5 hours. Next one. Find two consecutive even integers such that the sum of their reciprocals is 7/24. Well, let's just kind of break this down word by word here. It says find two consecutive even integers. So like 2 and 4, those are consecutive even integers. They're right next to each other, they're both even. 4 and 6, alright, these are two consecutive even integers. 8 and 10, these are two consecutive even integers. 6 and 7 is not consecutive even integers. 7 is an odd number. So you know the answer isn't going to be C, so you can eliminate that one. And 6 and 8, these are two consecutive even integers. So it's either A, B, or D. Now it says, such that the sum, so that means you're going to add them, the sum of their reciprocals is 7/24. So if we have two even numbers, let's just take this one for example, 4 and 6. Now as a number, as a fraction rather, it's 4/1 and 6/1. Yes, that's how we write them in a fraction. So their reciprocal would be 1/4 and 1/6. That's what the reciprocal means. So as we write this equation down now, the sum of their reciprocals, 1/4 plus 1/6, which one equals 7/24? Does this one equal 7/24? That's going to be our question. Or is letter B the correct answer? Does 1/8 plus 1/10 equal 7/24? I don't know. Let's find out. And the last one is going to be our letter D. Does 1/6 plus 1/8 equal 7/24? All you simply have to do, class, is put this in your calculator. That would be the easiest way to solve for this one. So let's do 1/4 plus 1/6 in our calculator. What is 1/4 plus 1/6? What happened? Why isn't my calculator working? Sorry about that, class. I think my calculator is working now. So we're at 1/4 plus 1/6. Does that equal 7/24? 1/4 plus 1/6. Is that 7/24? And no, it is 5/12. So I know that letter A is not the right answer. This is not correct. So let's now try letter B. What's 1/8 plus 1/10? 1/8 plus 1/10. Do I get 7/24? Do I have a winner? And I get 9/40. So evidently that is not the correct answer either. So it must be letter D. Let's find out to make sure. 1/6 plus 1/8. 1/6 plus 1/8. And do I have a winner? Yeah, what? Oh, I put 1/66. Okay, let's try this again. 1/6. There we are. Plus 1/8. And now do I have a winner? There we go. 7/24. So our answer, we were looking for 7/24. Our answer is letter D. So hopefully that wasn't too difficult. It might seem a little bit intimidating at first, but two consecutive even integers such that the sum of their reciprocals is 7/24. You just take your A, B, C, D options, put them as a reciprocal, so 1 over that number, and in your calculator, try to find the number that it's supposed to equal, which in this case is 7/24. Number 6, this one says the sum of the reciprocal of a number and the reciprocal of 9 less than that number is 7 times the reciprocal of the original number. Find the original number. Once again, this one might seem very intimidating, but let's just break this down one sentence at a time. The sum of the reciprocal of a number. So what number should we call that number? Well, let's just call it x. So class, x as a fraction is x over 1. So what is the reciprocal of that number? Well, it is 1 over x. The reciprocal just means that you flip the fraction upside down. So your original number is x, so the reciprocal of that number is 1 over x. Okay? So the sum of the reciprocal of a number, so here's the reciprocal of a number, is right here. And you want the sum, so you're adding the reciprocal of 9 less than that number. The reciprocal of 9 less than that number. So if our original number was x, right, 9 less than that number is x minus 9. So here's kind of like our original number. And then here is our second number. It's 9 less than that number. So if we want the reciprocal of 9 less than that number, right now it's over 1, correct? So if it's the reciprocal, it would be 1 over x minus 9. Okay, so our original number is x, the reciprocal is 1 over x. The second number is 9 less than that number, so the reciprocal of it is 1 over x minus 9. Is means equal, so here is our equal sign. That equals 7 times the reciprocal of the original number. Well, here's the original number, it is x, so 7 times the reciprocal would be 7 times the reciprocal, which is 1 over x. Find the original number. So what we are looking for is we are looking for x. So now we have to solve this equation. Right here. So once again, I'll just kind of talk about where I got all these numbers from. It's the sum of the reciprocal of a number and the reciprocal of 9 less than that number equals 7 times the reciprocal of the original number. That's where all three of those numbers came from. So I'm just going to multiply this one right here. So I still have 1 over x plus 1 over x minus 9. That equals, well, 7 times 1 is just 7, and 1 times x is x. So it equals 7 over x. So now this is the equation that I'm going to use to solve for x. When I solve an equation, what I need to do, just like with that Matthew and Josiah problem, is I have to get a common denominator in order to solve. So what is the common denominator that I multiply everything by? It would be x times the quantity, x minus 9. You get all the factors of the denominators, x, x minus 9, and x. Well, the least common multiple is x times x minus 9. So now I'm going to use this and distribute it to every single term. So with our first term, this x and this x cancel, so it's 1 times x minus 9, which is x minus 9. So now with my second term, this time the x minus 9's cancel, and now it's just x times 1, which is x. And then for my last term, I'm going to clean this up here, x times x minus 9. What cancels in this one? It is the x's, so it's 7 times x minus 9. 7 times x minus 9. Okay, now we don't have any denominator anymore, so now this is much easier to solve. On the left side, 1x plus 1x is 2x. 2x minus 9 equals 7x minus 63. So now I'm going to subtract 2x, and I'm going to add 63. So I get 54 on the left, and I get 5x on the right. And then finally, solving for x, I divide both sides by 5. So x equals 54 fifths. Is that one of my A, B, C, D options? Letter B. 54 over 5. So that's how you solve problem number 6. And lastly, problem number 7. It probably looks the most difficult out of all these problems, but in all actuality, it's the easiest one of all these problems. The production of the rate of a small factory is modeled by this equation. If you're interested in owning a small business or working for a business, you're going to have equations all the time in how things are deducted or how your funds are occurred and stuff like that. And you're going to have a bunch of different equations for all those things. And this particular expression is for this small factory. While the production of another factory is modeled by this equation. Okay? If you were to combine these two factories, what would the production rate be? Well, combine means add. So what is x plus 24 over 4x times the quantity x plus 3 plus 9x plus 24 over 4x times the quantity x plus 3. Well, if you were to add these two up, you're basically adding two fractions. In order to add fractions together, what do you need? You need common denominators. Do you have common denominators? Yes, you do. They are both 4x times the quantity x plus 3. So if you already have common denominators, this one is really quite simple. Your common denominator is 4x times the quantity x plus 3. And now you're just going to add up their numerators. 1x plus 9x is 10x. 24 plus 24 is 48. That's all it is, class. I believe this is how Excel Math always answers their questions on this problem. Just to let you know, if it was for me on a test, I would want you to factor the top by taking out a GCF. So I would want you to have factoring out a 2. Now it would be 2 times the quantity 5x plus 24 over 4x times the quantity x plus 3. And then lastly, this 2 and this 4 reduce. So instead of 2/4, it would be 1/2. So this is the answer I would want to see on a test. So those problems might be kind of intimidating the first time you look at them, but the procedure is the same on all 4 of them. So if you took good notes on 4, 5, 6, and 7, I don't think Objective 107 and 108 should be anything too difficult for you. Be sure to let me know if you have any questions on those.